Hi guys, you're welcome to God Academy. In this lesson, I'll be taking you through three-phase unbalance system. In our previous lesson, we've gone through the balance system, solved some power problems and others. So if this is the first time you're visiting God Academy, please subscribe and make sure you share. So in an unbalanced system, you can see clearly this configuration, which is star, right? So when you say system, as explained in our earlier tutorials, I said that a system comprises a generator and a load. So this is the generator and this is the load receiving, right? So this is an unbalanced system because our Z1 and the Z2 and the Z3 are not of the same magnitude. Therefore, there is an influence on how we solve it. At this point, I believe that you have the star configuration captured correctly, right? Where you have 0, negative 120 and positive 120. I think for you to appreciate this, you need to solve a problem. So let me give a problem here, then we kindly solve it. So is that for the system in the figure above, determine the load current if the supply voltage is 415 volt and D1 is equal to 8 plus J0 ohm, 2 is equal to 0 minus J8 ohm, and Z3 is equal to 0 plus J8 ohm. Yeah. So look at the problem. It says that for this system you see here, if our Z, which is here, this is the load, right? An unbalanced load. So that we have 8 purely raw number. We have Z2, which is 0 minus J8. We have Z3, 0 plus J8. How do we find the current, the load current here, if the supply voltage is that? So we need to find the current in each phase, okay? The current in each phase as well as the current in the neutral IN. Also important. So let's solve and see. So this is as simple as possible, okay? You find with regards to each phase. But let's see. If the voltage supply is 415, remember we are dealing with star configuration. In star configuration, our VP becomes what? VL over square root of 3. Is that not it? Which is 415 over square root of 3. As usual, 240 volts. Then you move straight to finding the respective phases. So I in phase 1, right? Or Z1 is equal to, in Z1, you realize that the voltage coming, this is unbalanced. The voltage coming here is what? 240 angle what? 0. So I have 240 angle 0 over my what? I. So I is equal to VP. I forgot to write that. So our IP that we are looking for now is equal to our VP over what? Our impedance, CP. That gives us our I. My impedance is what? 8 plus J 0 ohm. And what's the answer? The answer is simply 30 angle 0 ampere. As simple as that. You divide, we get 30, and the angle to what? Subtract is still 0. This is a complex representation if you remember. Our I phase 2 or Z2 is simply equal to that one. You know that in the second, when I come here in the second one, I have V angle negative 120. Take note, V2 is negative 120 and V3 is positive 120. So I'm going to get 240 angle negative 120 over 0 minus J8 ohm. Remember here, this is linear and this is polar. You need to convert from linear to polar, alright? To convert from linear to polar, remember that this is a purely imaginary number on the negative side. So if I represent this on a complex number, I'll have 8 somewhere here, right? And that is following on the imaginary. So therefore, my R is equal to, my R is still going to give me 8. Then when I come to my angle, my argument is what? Perfectly 90. Okay. So that's going to give me negative 90. Sorry, it will lie on the negative side, negative 90, because it's negative J8. Okay. So this simply becomes 240 angle negative 120 over 8 angle negative 19. Then once you have this, our answer 8 divided, you get 30. Negative 20 minus 90, which is negative 30 degrees amperes. Finally, our I in phase 3 or Z3, we're going to get 240 angle plus 120 over, it has 0 plus J8, right? And remember, this is the same as what? 8 angle positive 90. So this will simply give me 30 angle 30 degrees amps. Now finally, we have to find the current in our neutral because you're dealing with star. We add 30 angle 0 plus 30 angle negative 30 plus 30 angle 30. To add this one, you have to convert to linear. So you have 30 cos 0, 30 sine 0, 30 cos negative 30, 30 sine negative 30, 30 cos 30, 30 sine negative sine 30. You add all your sine components and all your cos components, and you find the square root of that. You should get 82 amperes, and that is the end for our lesson in three phase. I'll see you in the magnetic circuit class, and don't forget to subscribe, please.